Welcome back to our YouTube channel. Today we want to look at the titration calculation of Waec chemistry practical. Let's take this question as likely question that they may ask from you in your examination hall. And this is the equation for this question. Now the first thing that you have to know is that you have to do an experiment called titration experiment for you to determine your endpoint. But actually, your teacher would have given you your endpoint so that you don't waste time doing your titration experiment. So for you to save your time doing the examination hall, kindly ask your teacher for your what? For your endpoint, for your titer what? Value, and formulate your table based on the titer value that your teacher is going to give to you. Let's say assuming the titer value that your teacher gives to you is 20.2 cm3. Now just formulate your table to see that your average titer value is going to give you 12.20 cm3. So let's quickly rush through how you can formulate your table to get your average titer value. Looking at that, the titer value that your teacher gives to you that you use is 12.20 cm3. Now let's come to our table. These are Burette reading. These are rough titer, our first titer, second and third titer. Now we can just pick anything for our rough titer value. Let's say it's cm3. This is your final reading. If your initial reading is 0.0, that means that you have filled your Burette to the what? To the top. So let's say this one is 0.00. That is your initial Burette reading. So after the whole thing, the volume of acid you use, you are going to subtract this initial reading from your final reading. So that becomes, at this stage, you still have 12.80 cm3. Sorry, you don't need to write cm3 here because your cm3 is already here. Alright, so now this is your rough titer value. Now, but you have to formulate this, your first, second, third of your titer value in such a way that your average titer value will be 12.20. So what are you going to do? You have to make sure that you are going to get one of your volume of acid used to be maybe 12.10. Then you get another one to be 12.20. Then you get another one to be 12.30. Now that is 3 titer value. If you add the things together and you divide by 3, you are going to get 12.20. So now what I'm going to do is, and your initial value can be anything. Knowing that your Burette reading is from 0 to what? Is calculated from 0 to what? 50 cm3. But the initial reading, can be 0. You are starting from 0 and you are running your what? Your acid into your what? Into your base. So for you to formulate your table, you may do it in such a way that your initial value is not starting from 0. You can make it 10, that you are running from you are starting running your acid from 10 cm3. So here you can make it, you can say you are starting from 10.00. That's your initial Burette reading. So that everything don't look like 0.00. That's where you are starting everything. So you may fill up your acid to make sure that it's what you are starting from 10.0. And this case also, I can still increase it, knowing that if I add it to what I want to get is no more than what I want to get. So I can still leave this one. I can say I still start from 10.00, and here I start from 20.00. That is your initial reading before you start to run your acid into your base. Now I have to add 10 to this value that I want to get, so that I can get my volume of acid use. So if I want to get, let's say I want to get 12.10 as one of my initial value, then another one 12.20, another one 12.30. This was the value that I want to get. Because if I get this value and I add everything together, if I divide, I'm going to get this middle value. So whatever you want to get a value before that value and another value after that value. Be adding 0.1 to your initial value. So if I want to get 12.20, I'm going to get 0.1 less than 20.20, and I'm going to get 0.1 greater than 12.20. So that's how you are going to be formulating your your theta value. So here I want to get 12.10, so I'll add 10 to this one, so that will give me what? 22.10. So that if I remove 10 from 22.10, it still give me what? 12.10. So if I remove that, I will get 12.10 from this place. So here I want to get this place, I want to get 12.20. So what I will do, I will add 12.20 to my initial value, so I will give my final reading. So that if I remove from the initial, I will get the value that I'm looking for. So here I will get what? If I add 10 to 12.20, I'm going to get 22.20. So if I subtract it, I will get 12.20 here. But this, and note that this is 20. That is the initial point of running my acid into what? Into my base. That is my initial reading. So I'll add it to 12.30 because I want to get 12.30 as my volume of acid used. So this one will give me, it will give me 32.30. So if I remove 20 from 32.30, I'm going to get 12.30. And don't forget, your reading must be in 2 decimal places. So you see that everything is what? 2 decimal places. So that for me to get consistent what? Value. So this is my what? My first theta, second theta, and third theta. To get my average volume of acid to use, I'm going to add all these theta values together and divide by what? By 3. So my average theta value now will be 12.10 plus 12.20 plus 12.30 divided by 3, and my answer will be 12.20 cm3. Because I know that if I add the things together, it's going to give me my middle what? My middle value. Don't forget, any value they give to you, get 0.1 that is less than that value and add 0.1 to greater to that what? To that value. So it is minus 0.1 of the value that you want to get, then plus 0.1 plus what? Of the value that you want to get. Add the things together. If you divide it by 3, you are going to get the middle number that you are looking for. Let me give you one example, one more in formulating your table, because you are dealing with how to formulate what? Your table. Let's say for instance, I want to get 15.00. I want to get this as my theta value. So I'm going to get 0.1 less than this value and 0.1 greater than what? This value. So I'm going to get what? 14.90 here. Do you understand? Then I'm going to get 15.10. So I've removed 0.1 from my value that I want to get, and I've added 0.1 to the what? Value that I want to get. So if I get this one as my volume of acid use, if I add these things together and I divide it by what? By 3, I'm going to get 15.00. Do you understand? That's how to formulate what? Your table. Any value they give to you, minus 0.1 from the value that you want to get, and add 0.1 to the value that you want to get another value. Add the things together, divide by 3, you get what? The value that you are looking for. That's how to go about this table. So this is how to formulate your table after your teacher might have given you what? Your theta value, because you need your theta value as your volume of acid use with your VA that we're using in our calculation, knowing that your VB is always known depending on the pipette that you're using. We are using 20 cm or 25 cm3. So let's go to our calculation, because we have known our average theta value, which is our VA, volume of acid was used. So let's go to our second part of this work that I want to do today, which is dealing with a titration calculation that may come out in your Waec examination, and that's what we want to do for this second part of this work. Alright, let's continue with our calculation that we have for today. Knowing that, let's write our parameter out. If you want to solve any calculation question, write your parameter out first. Now we are getting our VA. to be what 12.20 cm3. Now, let's say the pipette that we are using is 25 cm3. Now that will be our volume of what the base. So our PB is 25 cm3. That is the pipette, the volume of pipette that we are using. Now from our equation, we are going to get our number of acid use, number of mole of acid use, and we are going to also get what the number of what the number of mole of what of base what use. So our Na is number of mole of acid use, and here what is here 1. Then for our number of mole of base, that is what, that is 2. So that's our parameter. Now coming back to our question, he said to calculate the condition of A in mole per dm3. That is our first calculation that we want to do. But note that from your question, they are giving you the solution of A, which is 3.0 gram in 250 cm3 of H2SO4. So they are giving you how many mass of H2SO4 they dissolve in what 250 cm3. And note that your concentration can be mass concentration or molar concentration. So here we want to get our mass concentration of H2SO4, so that we can use to calculate our concentration of A in mole per dm3. So from our question here, our H2SO4, they gave us that they dissolve 3.0 gram in 250 cm3. But note that for our titration calculation, your concentration must be in mass concentration or molar concentration. And for your mass concentration, the unit is in gram per dm3. Our mass concentration is in, the unit is what? Gram per dm3. What does it mean? The amount of mass of that substance that is dissolved in 1 dm3, and your 1 dm3 is 1000 cm3. So for us to continue with this question, we must know our mass concentration, because anytime you do your titration calculation, you will be finding two things. It's either you have to calculate your mass concentration of acid use, or the molar concentration of acid use, or the mass concentration of the base use, or the molar concentration of what the base use. That is the what concentration that you are going to find. Now, and that's why we have to first find our mass concentration of H2SO4. They didn't give to us, but through this parameter they gave to us, we can find it, because they are giving that they dissolve 3.0 gram in 250. But what are we looking for? How many gram will be in 1 dm3, which is what 1000 cm3. That will give us our mass concentration. So you have to find your mass concentration out. So let's find our mass concentration. Since we know that if they dissolve 3.0 gram in 250 cm3, what are we looking for? How many mass will be in 1000? That will give us our mass concentration based on the unit of mass concentration. So let's find how many mass will be in what? In 1000 cm3. Do you understand? So what do? We cross multiply 3 in 250. You can also use your simple mathematics. So how many 250 are you going to find in 1000? That is 4. So if 3 is in 250, how many will be in 1000? That is 3 times 4. That will be 12. Do you understand? And you can do your cross multiplication. If that is what you want to use in 250, how many grams will be in 1000? So let's cross multiply. That will give us 3 times. That will be 250. 250x is equal to 3 times 1000. To get our height, divide both sides by 250. Divide both sides by 250. So our x is, how many 250 in 1000? That is 4. So that will give us 12 gram per dm3, which is also mean 12 gram in 1000 cm. So this is what we need. This is the mass concentration of H2SO4. Now, but what they ask us to find? They say you should find what? Concentration of A in mole per dm cube. But we have gotten concentration of A in gram per dm cube, which is our molar, which is our what? Mass concentration. So the next thing for us to do is now to convert mass concentration to molar concentration, which is what they ask us what? To find. Right, let's convert our mass concentration to what? To molar concentration. Now, there is a formula that connects molar concentration and mass concentration together. And you have to know that in titration, we usually use two formulas, make the two formulas to solve our question based on molar concentration and mass concentration. The first formula that connects molar concentration and mass concentration together, which I want to write, is concentration in mole per dm cube is equal to mass concentration in gram per dm cube over molar mass. Now, this first formula that we use in what? This one formula that we use in our titration experiments. Now, another formula is CA/BA over CB/BB is equal to NA over NB. Now, this first formula that we have is formula that we can use interchangeably. If they are giving you concentration of a substance in mole per dm, and they have to calculate the mass concentration, now you can use this formula. Since you have known the molar concentration, then you can find the mass concentration. Or if they are giving the mass concentration of a substance and they have to calculate the molar concentration, you just plug in your molar concentration here and find what discuss your mass concentration and find what molar concentration. So this formula can be used to find, to connect both molar concentration and what mass concentration together. Do you understand? But this formula here is only used to calculate the concentration of acid or base in mole per dm cube. You can use to calculate the mass. You can use to calculate the mass concentration of acid or base. No, you can only use to calculate the molar concentration of the acid or the base. That is what your Ca and Cb represent. Is the concentration of acid in mole per dm cube and concentration of base in mole per dm cube. So you can only use to calculate concentration in mole per dm cube only. But this formula can use to calculate concentration of both in mole per dm and in gram per dm cube. So now let's come back to our question. We have from our first calculation we have gotten our mass concentration of the acid, mass concentration of A, and we got it to be 12 gram per dm cube. So they now ask us to calculate the molar concentration of A. So this is the formula that we can use because it connects both molar concentration and it connects both mass concentration and molar concentration together. So that's what you have to master. Anytime you have gotten your molar concentration and you want to find your you have gotten your mass concentration and you want to find your molar concentration, use this formula. Or they are giving you the molar concentration of acid or base, they have to find the mass concentration. You can see this formula. Now, so let's use this formula to find our molar concentration of the acid. So it now becomes our concentration of A in mole per dm cube is equal to mass concentration of A in gram per dm cube over molar mass of A in gram per mole. So this is not what we want to find. Now let's plug in the formula. So we have our concentration of A in mole per dm cube. Which what we want to find? We have gotten the gram per dm cube, the molar concentration over the molar mass of A, and our A is H2SO4. So let's find the molar mass. Our hydrogen is 1. How many molar of hydrogen are there? 2 times the molar mass of hydrogen 1 plus how many sulfur? 1 times what? The atomic mass. The atomic mass is what? 32. Do you understand? Plus how many atoms of oxygen? 4 times what is the atomic mass of oxygen? 16. So at the end, if you do the calculation, we have 2 plus 32 plus 4 times 16. That is what? That is 64. Let's add everything together. This will be 34 plus 64, and that will give us what? 98. So here we have 98. So that is over what? 98. So let's use our calculator to do the stuff. Now after our calculation with calculator, we have 0.1224 mole per dm cube. Try to make sure that your answer is what? In 4 decimal places. And after you want to use this answer, make sure that you use the long value to do your calculation and not the one that what you have summarized to what 4 decimal places. You want to continue to use this value in your calculation. And don't forget to write how you got your molar mass of H2SO4. Let it be in your calculation. Yes, so that you see how you got it out. It's what? It's also carry what? Mark. Now let's go to our second question, and that will be very fast if you want to go to calculation of other one. So let's go to the second question, which is condition of B in mole per dm cube. We want to find concentration of B. Now, you remember this formula I told you? CA BA over CB BB is equal to NA over NB. You know, I say we used to use this formula to calculate condition of acid in mole per dm cube or condition of base in mole per dm cube. Now, since you have gotten CA, we have gotten our CA to be 0.1224 mole per dm cube. Now this formula, once you get one of the condition of acid or base in mole per dm cube, if you have to calculate the second one, you will use what? This formula what? To calculate it, because you have known one of the condition of the acid or base in mole per dm cube. So now you have known A, you can now come and find what? B. So let's just plug in our value. So we have our 0.122, that's our CA, times our BA, volume of acid, 12.20 over condition of B in mole per dm cube. I don't find CB times what is the volume that we have here? 25 is equal to number volume of acid, which is our Na is 1 over our Nb 2. What do? We cross multiply. If we cross multiply, we are going to have our CB times 25 is equal to 2 times 0.1224 times 12.20. Now, what do? We divide what? Both sides by 25 to get CB. So we have, make sure that you don't drop any step. Divide both sides by 25. Each steps matter because it will carry what? Mark. If you don't drop step, you have CB times 25 divided by 25 is equal to 2 times 0.1224 times 12.20 over 25. So our CB, here we use our calculator. Let's use our calculator. Sorry, I made a mistake here. I should cancel CB. This is 25 and 25. After the calculation of everything, we got 0.1194 mole per dm cube. So this gives us our condition of B in mole per dm cube, and we have gotten Ca, we have gotten Cb. Now let's go to the next question, which is what? Molar mass of XOH. Now let's go to the third question, which is the molar mass of SOH. Now our SOH is our base. Now we want to find out molar mass of SOH. Don't forget that in our titration calculation, we majorly use what? Two formulas. Now let's look at those two formulas. You know that if you look at the formula that contains molar mass, that is the formula that you can use to calculate this question. So formula is concentration of SOH in mole per dm cube is equal to mass concentration of SOH in gram per dm cube over molar mass of SOH in gram per mole. Now, this formula that we can use, because it is in this formula that we can find molar mass. We can't use that second formula of CABA over CBB is equal to NA over N, because we can't calculate molar mass from that formula. So this formula that we can use. And knowing that we have gotten the condition of B in mole per dm cube, we have also gotten what? Condition of what? Mass condition of what? B in what? In gram per dm. We just plug in the formula and find our what? Molar mass. So what do we get here? That is the one that we got now. We got 0.1194. Don't forget, that is the condition of B in mole per dm. That's what we got. Do you understand? It's equal to then the mass condition of B in mole per dm cube. Now let's come back to the question. They said B contains B is a solution containing 1.4 per 250 of what? SOH. So we need to first find that one before we can proceed with our question. Now, don't forget, we said that we need this 1.4 per 250 cm cube. This amount of mass in what? In 250 cm cube of B. That's what they give us in the question. But to get your mass condition, you want to get how many mass in 1000. That will give you what? Your mass concentration, which is what? How many grams is in 1 dm cube, or how many grams is in what? 1000. So we need to find that one. How many grams per 1000 cm cube? That will give you my mass concentration. Now, so that's what we want to do. So we now do that. Let's do that. That will be 1.4 gram. We solve it in 250. How many grams will be in 1000, which is my gram per dm cube? Now what do? We cross multiply. So we are going to have 1.4 times 1000. Our S is 1.4 times 1000 divided by what? 250. So how many 250 here in 1000? That is 4. So if you multiply our 1.4 times 4, we are going to get 5.6 gram per dm cube. So this is my molar condition of what? Of B. Now let's plug it into our formula. We start it here. So we have 5.6 gram per dm cube over what we want to find? Molar mass of SOH in gram per mole. So what do you do here? As an student, all you do is cross multiply. So we have gotten this one, so let me clean this side. So now let's cross multiply. So we are going to have 0.1194 times molar mass is equal to 5.6 gram per mole. We have divide both sides by what? 0.1196. So divide by 0.119. Sorry, divide by 0.1194. So let's divide it by 0.1194. They do also what? Divide by 0.1194. So our molar mass of SOH will be, let's use our calculator. Now after our calculation, we got 46.90. That is our answer. Now 40.90. Now we have gotten our molar mass of SOH. So let's go to the next question. Which is the what? The fourth question that we have here. The what? The relative atomic mass of X. Now to do number 4. Number 4 is relative atomic mass of X in SOH. Let me put it like that. Now, I want to find how many S is in what? SOH. We want to find what is the atom of X, atomic mass of X in that SOH. So, knowing that our SOH molar mass is equal to 46.90. Now that will now be my X now. My X plus how many oxygen is here? 1 times what is the atomic mass of oxygen? 16 plus my hydrogen is what? How many atoms here? 1. What is the molar mass of hydrogen? 1. That will be 1 times 1 is equal to the molar mass of the what? Of the compound, which is what? SOH. So that is what? 46.90. You know, we have to know the atomic mass of other atom to find what? The unknown. So this now become S plus 16 plus 1 is equal to 46.90. So this will be S plus 17 is equal to 46.90. So our S will now be 46.90. You carry this to this other side, minus 17. Our S is there. So our answer is 29.9. So the atomic mass of X in SOH is 29.9. Now let's go to the last question. Let's go to the last question. This one is in gram. This one is also in gram. Gram per mole. And let's forget that. So let's go to the last question. To the next question that I want to calculate. I want to calculate the mass of H2SO4 in 50 cm3 of the solution. Now, how many mass of H2SO4 will be in 50 cm3? Let's want to find. But from our question, we can solve this question. You know, they have given us that in our question, we have 3.0 gram in 250. Now, this becomes our stoichiometry what? Standard to calculate what? The question. Now, we have known that in 250 cm3 of H2SO4, how many mass is there? 3.0. So 3.0 gram in 250 cm3 of H2SO4. So they are giving us this parameter in the question. Now the question is, if it's in 50, how many mass will be there? So you just say that how many mass H gram will be in what? In 50 cm3 of H2SO4. The reason why it's easy for us to calculate this question is that they have given us a kind of parameter in the question that we can use to relate what in the question they are asking from us. So from this case, we have 3.0 gram in what? In 250 cm of H2SO4. How many gram of what will be in 50 what? In 50 what? You are going to what? Cross multiply. And for your mathematics view, you can also, you don't even need to multiply before you what? Get your answer. How many 50 can we get in 250? That is 5. So you just try to divide what? 3.0, you get your what? Your answer. And you can also use cross multiplication. 3.0 in 250. How many x will be in what? 50. You cross multiply. That was 250 x is equal to 3 times 50. So we divide both sides by what? 250. Divide both sides by 250. So our S is 150 divided by 250. So let's get our answer. Now with our calculation, we got 0.6 gram. That is in 50 gram, in 50 cm of H2SO4, it is 0.6 gram that we are going to dissolve in it. So that becomes our last calculation for today. But do not forget that when you are getting your theta value, the range of your figure, if your teacher has given you your theta value, know that your own theta value you are going to get must be between the range of plus or minus 0.2 cm. Plus or minus 0.2. The range must not be what? Must not be higher than that. Plus or minus 0.2 to get your what? Your real theta value. And don't forget the skill that I taught you. I taught you the skill that to get your average theta value. Now, pick your average theta value that you want to get. Then do minus 0.1 for it and plus 0.1 what to that theta value. Now, if you add that theta value together, if you divide by 3, you are going to get the actual theta value that what you want to get. Now, this brings us to the end of this aspect. And also, do not forget, if you need us to explain any other aspect of this titration calculation for you, do not forget to drop it in the comment box. Also, do not forget to like this video, comment, share with your friend, and lastly, do not forget to subscribe to our YouTube channel.